So I'm Jamie Geiger, and I'm here to give you a talk on function hooking with Xposed. So grab that link right there, tinycc/BSides-rock-Xposed. That is the whole presentation. All of the links, all the code, and all the stuff that you guys need from this presentation are going to be at that link. This will link directly to this presentation. You'll be able to look at it. You can follow along and grab the links from there. That's the easiest way, I thought, to distribute all this stuff, because there's a couple different GitHub repos and things. So grab that. If you guys have any questions throughout this entire presentation, just please stop me and ask a question. If I'm going too fast, if I'm talking too fast, if I say something that doesn't make any sense, call me out. I'm open to that. I want to make this presentation good for you guys and have it be educational. So, yeah. So without further ado, we'll move on. So our agenda for today is a who am I, who are you kind of intro thing. We're looking into tools. This presentation kind of turned into an intro to reverse engineering Android as well as Xposed. You can't really use this Xposed framework thing without reverse engineering some Android applications. So we're going to look into that. What to hook, finding the functions within the applications that we're going to be talking about, finding the functions you want to hook and take advantage of. Basic hooks, writing basic hooks to replace methods, to do all sorts of different things. We're going to have a couple practical examples. These last 3 bullets, each one has a practical example. So basic hooks, we're hooking codes, changing return values of things. Reverse engineering, there'll be times where you have an application and you need to figure out what it does, but maybe there's something in the way or there's some sort of strange algorithm to calculate something. You can kind of make the app do the work for you in that case. And then disabling security checks, specifically certificate pinning, so you can kind of get in the middle, and we'll show man in the middling some traffic after we disable certificate pinning within the app. So we're going to go through all this and more, I promise. So here's the intro. I am Jay Geiger, Wumbo.in. I like SpongeBob. I'm 22, it's fine. InfoSec at RIT, it's my last year, I'm graduating. I'm going to a company called Grim after graduation, grimco.com, very small, 15 people now, really cool place to work. My hobbies and interests, CTFs, reversing exploitation, all that stuff, poking Android, collecting acronyms. What is it with this field in acronyms? Yeah, these acronyms are crazy. So red team malware development, that's some of my other work that I do, but I like Android, so working on that. So, who are you guys? So, this is a little audience participation part. Any RIT students? Raise your hands if you're RIT students. Just make sure you guys are awake. I gotta gauge my audience before I do anything. Java programmers? Anyone program in Java before? A couple people? Alright, good, good. Android users. How many Android users we got in here? Yeah, there we go. It's good. Android application programmers have done any app dev or anything, okay? Used Xposed before, heard of it. Ah, there we go. This is good then. Written any Xposed modules? We got any people in here that have done that? Excellent, this talk will be perfect then. None of the above. Any of the people, it's just, all right, there we go, people, none of the above. Perfect, so this talk is still for you, don't worry. So what is an Xposed? Sounds hot, yeah, it is. It's really actually awesome. It's a function and resource hooking framework. So that means you can basically take a function or resource that an Android application uses and change it to do whatever you want it to do. So returns, parameters, exceptions, all of that, and UI elements. The UI elements part is not something I'll be covering in this talk because this is a huge topic. Like this framework does a lot of stuff. So we're going to go entirely for the function hooking part of this. UI elements is something else that I'm looking into even, and it's kind of complex. I'm not really an app dev, so this stuff has kind of been interesting for me to look into. So it's written and maintained by this guy named Robo89. There's his GitHub. He has all this stuff as open source, his Xposed framework, which is a modified app process. He's got that on there. He's got the Xposed bridge, which is a Java jar, which we'll be talking about. It's all up on there, so you can go look at it and see how it works. So like I said, it replaced the app process, which is actually the next slide. How does it work? It doesn't change an app signature. This is a question that I got from someone when I showed them this talk before. It was, or when I was practicing it. Does it change the app signature? And no, it doesn't. It doesn't modify the application that you're hooking in any way. It does in the background, but it does not modify the package itself. So it's a replacement app process that basically adds this Xposed bridge jar to the class path. And any Java programmers know what a class path is. It's basically where it loads all your resources, like an include for C. So you're including this jar that basically has a bunch of functions that you can call. So when the first process on Android is called Zygote, and every process forks off of that. So if you can hook into Zygote, which is launched via app process, you can hook into every single process that launches. Zygote is actually like a Java process, like launched by app process, and then every application is forked off of it. So if you add a Java class, a jar, to that app process module, you can actually get that into every single application that loads on the device. So that's how this is all done. So yes, for anyone who asks, you need root to do this. This talk is more of like a, for your own personal, like, okay, I want to do this with this application knowingly. You're not going to put this on someone's phone and use it for like a covert, like a backdoor or something. So tools, they live among us. So I got to explain some tools before we go any further. So you guys are kind of aware of what's out there for Android reverse engineering. When you get an application, an APK, Androids run these APK files. They contain all the resources, all of the Java classes and everything, and they're written in Java. So you need a Java decompiler to really look. You can basically look at the source code. Sometimes it's obfuscated, sometimes it's not. But these two tools will basically allow you to decompile Android applications. The one that I'm going to be taking advantage of in the demonstrations that I'll be doing is JAD, which I found more recently, but the decompilation seems a bit better. It takes the Java classes and it just basically takes the bytecode and puts it back into like pseudo Java for you to look at. So it's a lot easier to look at than Java bytecode, which is really obnoxious. Dex2Jar, an APK tool. The way that you need to convert your APKs to jars, so that's why we have Dex2Jars, because inside an APK there's this thing called a dex, and classes.dex, and that's basically all the code for the application in this one file. Dex2Jar takes that file and converts it to a Java jar so that you can actually decompile it with these with JAD or JD GUI. An APK tool is useful if you're reverse engineering an application as well. It extracts the Smalley, the Java bytecode, and then the resources from the package, so you can look at those and change them if you want. So AAPT, I'm going to be using this one actually pretty heavily. It's part of the Android SDK, and it allows you to see the resources inside a package without unpacking it. Your decompiled code doesn't have all of the strings that you're going to need to look for, because if you're reversing something, you're going to be looking. One of the first things you look at is strings. Okay, I'm going to find this certain string that I think is pertaining to the part of the program that I'm trying to get to. The strings aren't all in the application, unfortunately. They're referenced by number in a resource. So you actually have to use this tool to find out where those resources are, and you can use this tool to actually look for all the strings within the application, and you can grep for them. So from there, you would basically say, okay, I'm looking for this string, it has this ID, and I'm going to grep for that in the code, the decompiled code, and now I know what location that string was at. So that's a kind of a unique thing with reversing Android classes that you kind of have to do, so we're going to be using that. I wrote some custom tools to help with this because I was tired of doing these commands over and over and over and over again, and I got really mad, as you can see at this last one, because sometimes there's obfuscation within these classes, within these jars, and sometimes they'll be named, the class files will be named like this: capital A, lowercase a, capital A, capital A, and I don't have a case-sensitive file system, so these overwrite each other as soon as they unzip. So I had to write this big, shell script, not really a big shell script, but a shell script to take it, check if it's already there, and then unpack it. This also has the shitty option so that you can unpack class or jars that have these ridiculous classes. So the first one will take an APK file. It will convert it with Dex2Jar to a jar. It will unpack it by just unzip. A jar file is simply a zip file, a signed zip file. And then it will unpack it and decompile everything, so you can start to look at all the code and all the classes. So it does that all in one. JAD actually takes a class file at a time, so it's really tedious to go through and, okay, I'm going to decompile this one now, I'm going to decompile this one now. So this tool basically helps you do everything all at once. Search string will allow you to use AAPT to search strings. If you find, say you're looking in the code somewhere and you find a reference, you can paste it as the second argument to this search string, and basically it will tell you what string that equals. So this number, this big long decimal number or hex number or whatever, you paste it and you can use that. I'll show you an example of that. I can show you an example of that later. So you can find them here. Like I said, all the links for all the tools for this presentation are in the presentation itself, so make sure to check those out. So what to hook? We have to find something to go after. This involves reverse engineering the application. So the process that I usually use, this is it. You got to get the APK first. You have to get a hold of this file that's the application. You can get it at apk4fun.com, which is, it'll give you APKs. Don't pirate things. I sometimes use this just to check out, okay, I'm going to poke at this application and grab it offline. I don't have a USB cable. I'm just trying to reverse it, poke at it. Or you can get it in this directory on your phone. So if you use an ADB shell and you get shell access to your phone, you need root to get to this area, but you need root to do all this Xposed stuff anyway. So you should have that already. Convert it to a jar with our dex to jar program. So that's literally dex to jar and the APK that you extracted. Decompile with either JAD or JD GUI, whatever you prefer. JAD is a command line tool only, and JD GUI actually has a GUI. That's the GUI part. Maybe smash your head against the obfuscation. Like I said, I'll actually show you guys later. One of the applications that I have is heavily obfuscated, and like I said, that's why I had to write that one tool. And the class names are just horrendous. Identifying the relevant classes and functions. So you can do that by standard reverse engineering techniques, looking through, seeing how things are connected, reading the code, understanding it, trying to find. I usually start out with strings, honestly, like looking at what strings are there. That's one of the demos actually we're going to do, is looking at something, trying to find out how it's doing something via the strings. So I've come up with a couple different scenarios to kind of give you an idea of what the use cases for this would be. So before we talk about those, this is the meat of the programming part. You need to understand what all of these things do to be able to program a module. The Xposed bridge is that class that we talked about before that gets loaded when the Xposed thingy, the Xposed hooks app process, or the modified app process loads the jar. This is the jar that it loads. You need this to be able to build these modules. They essentially compile to APKs, and the Xposed framework will allow you to enable them and disable them. Xposed helpers find and hook method. We're going to be living on this. It finds a method by class name and method name and parameters, and will allow you to hook it and change it into whatever way you want. Call method is something that I've used before. You can call methods out of line. I don't have a specific example of that in this talk, but I think it's a really cool thing that you can kind of do. Just, all right, and before this function runs, call this other function, and then get the return and do something as a result of that. Xposed hook load package is a class that a class you're going to implement. So you're implementing this to hook packages. So on app init, every time this will get loaded, and then you'll see you can check the package name. If it's the package name you're looking for, if it's the app you're trying to hook, you continue. If not, you just exit. XC method replacement and XC method hook are really important. Those are the two things that actually do the work for you, and they're used with find and hook method. So these two they do exactly what they sound like. This hooks a method, and this replaces it entirely. Load package param is essentially it's package information. We'll be using that to identify if this is the correct app that we're looking for when we're writing a module. And then the Xposed bridge, that's basically a logging helper that I'm going to be using a lot, so I threw that in the bottom. That's like the base Xposed bridge.logging. So module structure, I'm providing code in this talk for a skeleton. There's a skeleton creator. You run the script with a bunch of arguments. It'll tell you what they are, and it'll create a new module for you that's ready to build. So you can CD into it directly, and it'll hook the app that you want. Or it'll create a package for you that builds, and you can just modify the code from there so you don't have to spend time fighting with build stuff. So you need this Xposed bridge jar to build it. This is just the whole project structure. I'm not going to go over this too much because there's examples of it. The only important things to note are Xposed init, which is a new thing, which is added as an asset that basically says run this class when this module starts. Like grab this class, which is the one that'll be in here. Java, your company, whatever, app name, hooks.java. So this path, minus the Java, will be in Xposed init saying, when you load this module, load up this code, and that'll do the hooking. So a side note on building and installing, it's built with Gradle. It's a build system. The output is an APK, and it's sent to app builds outputs, APK, app-debug.apk. So that's the file you'll be installing on your device to install the module. Feel free to sign it if you want. This is just a debug app. It'll install just fine with this command right here. So I've been using that. I've just been using the debug versions, and it works just fine. So now we're actually going to get into the meat of the code of package hooking when a package loads. So like I said, load package, there's one of the things we've seen before, and another important part of this is the handle load package function. So we're using this, we're implementing this function, handle load package. So this function will launch every single time a package gets loaded up. So every time you open an app, every time an app opens, this will run. And so you have to check, is the package name equal to what I'm trying to find? If it's not, quit, just go up, just leave. If it is, then we want to hook methods. So this is the main skeleton that you're going to be using to hook applications. You can also hook UI elements in a different way by implementing a different class, and also Zygote itself, so the main Android process, which is pretty cool. But this is an application hooking talk, so I'm talking about just load packages. So any questions so far? I try to speed through the beginning because it's not the title of my talk, so this is the more important stuff. So this is all about find and hook method. Like I said, this is really important. We're going to be living on this. This is going to be our main thing that we're going to be using. It finds a class. It does exactly what it sounds like. It finds a class method by name and hooks it to do whatever you want, really. So there's 5 different scenarios that I've come up with and have small examples for, so you guys can get a feel on how this kind of works. You can return a constant, so true, false, 7, 89, SpongeBob, whatever. Ignore it completely. Just make the function do nothing. Do something before it's called, do something else entirely, or do something after it's called successfully. And so this is the main way you call this. You specify the class name that it's within. LP param class loader is always the second argument. The function name in quotes, and then if there's any arguments, you need to provide them in a certain way, which I'll show in my example code. And then the actual hook itself, which is one of the two that I showed before, XC method hook or XC method replacement. So you'll be implementing those. So our first scenario is really, we want to make that function just return a constant value. And this is useful for, hey, maybe you're verifying a passcode, and this app won't let you in unless you verify the passcode successfully. All right, so we want that just to return true. We don't care what it does. We just know that it verifies the passcode, and we have the correct passcode, of course. So this is going to be in com.bank.app.main, and it's always going to return true. So here's actually, when I said find and hook methods here, this is where you would put this find and hook method. So in class com bank app main, again, it's that same argument all the time. Verify passcode, takes a string as an argument. This is what I was talking about with arguments. So when this find and hook method is finding a method, it's going to look for a method called verify passcode in this class with that argument, string.class. We have to pass it as a .class. I'm not sure why, that's just the syntax. And then you're using XC method replacement, so we're replacing what this function does entirely with just returning a constant. We're going to return true. All right? And what that'll do is make this function return true every time. So that's really cool. Scenario 2 is we just want to make it do nothing. This is more like used for void functions, because usually non-void functions will expect some sort of return, and if it doesn't return anything, it could like crash your app. But there's void functions to do all sorts of things, like if we're just, we have a function called check security, and we don't want it to do that. No security here. Very similar, same kind of thing, except this time this one has no arguments, so there's no arguments after the function name itself. We have XC method replacement do nothing, which is fairly straightforward. This will just make this method not do anything at all. Do something before the function is called. So there's no code under here because it's on the next slide, because it's a little bit more involved. That's why it's the third. The third, fourth, and fifth are the more technically, they require more programming. So say we have a function called transfer funds, and it takes a string account number or something in the class combank app main. And we want to just, before the function runs, we want to change that argument to make it, say, our account number or a different one, whatever that may be. So instead of just your XC method replacement, you have to make a new XC method hook. And so essentially, we have to override the function called before hooked method. So this code will run before this method transfer funds runs. And you can access, it's really neat because you can actually access the arguments of this function right before it's called. And you can change them, or you can dump them to the logs, or do whatever you want with them. And so this is this Xposed bridge log I was talking about. This will dump out to the ADB logcat. So logcat's essentially Android's logging system. It'll dump with the tag Xposed. So if you grep for Xposed in your ADB logcat output, you can actually see this. Will come up with changed account number. And so you know it's working. I use this a lot for debug. That's what logs are for, I guess. So you have to override the method because you're creating a new XC method hook. And we'll be sticking with the XC method hook for a little while because that is before hooked, and it also has an after hooked method, which is the last case here. Any questions so far? Everyone still with me? Okay. Thank you for the head nods. I appreciate it. So we can do something else entirely instead. We can, make it crash the app or do something. So same bank example. Check password. Okay. String password. We're going to do kind of the return constant thing, but we're also going to dump it to the logs. So we're just replacing the method entirely, and we're going to say, okay, dump the password out. Might as well grab that while we're at it, and return true. So we're assuming this function returns a Boolean. So our friend XC method replacement is back. This time we're actually creating a new one, and we're saying override the replace hooked method function. And we're saying, okay, here's our program, by the way, that's got all the information about the arguments, the object that it's part of, and return values and things. Sorry, I forgot to cover that before. So we're logging it, xposebridge.log, and we're sending that. We know it's a string argument, so we're just casting it to a string to make sure it's a string, and just sending that to the logs. Simple enough. And then return true. So this function will now return true, always, and also give you the password, which is all right. Doing something after the function is called. So we have this function called generate token, and so in this case, we want to get a token. So we want to get a valid token that we can use to request things. Say this is a bank app that generates a token on the client side, and it's got a certain algorithm or something. I'm not really sure, but whatever it does, this returns a string that has a token. And we want to get it because we want to be able to make our own requests to their server, and we want to generate a token. So we'll dump it out to the logs. So we're just going to assume it returns that string. Back to our friend XC method hook, we're overriding, instead of before hooked method, after hooked method. So fairly straightforward. We're just logging out param get result. So I show this as an example because you can get the result of the function, put it somewhere, do something with it, and maybe if it's a certain value, do something else with it. Like you can write, whatever you can write in Java, you can do before or after or completely instead of other functions within Android applications. So it's really awesome. So I'm going to do the classic Words with Friends hack of Words with Friends client side. Is the words checking is on client side. So we're going to disable that and play whatever word we want. I managed to come up with a game where we both played shady off each other, which I think is pretty funny. So we have this game right here where this is about to be pretty shady because I'm going to get a lot of points in a couple minutes here. So I'm going to try to play. I like triple letters, right? I'll just play. I got J and Q. That's perfect, right? So I'm going to try to do this. The module that I wrote is not enabled currently, so it's going to yell at me and it's going to say, "No, that is not a real word." Which you can check any dictionary. I don't think that's a real word. So I'm going to enable this, and I'm going to talk about how you would go about finding this. So if you haven't seen the Xposed interface before, I'm just going to enable this and reboot. And then while I'm rebooting, I'm going to talk about how I actually found this, the process that I went through to find this. All right. And I wrote all my commands down, so you guys don't have to like painfully watch me type a bunch of commands in. So I'm going to spare you the decompilation of this because it's literally just without new line. Here's the command. It will decompile. APK decompile will essentially make a directory called out and a jar called out. Yes, I understand. And a jar called out. Out.jar and out. And inside the out directory is a bunch of, there'll be classes, but find out. There we go. So here are the decompiled classes. These are the full bytecode classes, and here are the actual decompiled classes .jad. So those are the ones we're going to be looking at. So let's use AAPT to find a string. So we're going to be looking for the word valid. I think that's a good choice because, we're looking for valid or invalid words. And I know that this is also somewhere where I can find the valid word check. So this is the one we're looking at right here. Sorry, whatever it is not a valid word. We saw that pop up on the screen when I tried to play that ridiculous word, and we're going to look for that. So AAPT also has another function, and it allows you, like I said, you can look at the resources within a package. So we're actually going to try to look for, sorry, this is not a valid word, within the resources and find the ID. Like I said, a lot of the times your strings will actually not be in the decompiled code itself. They'll be referenced by number. So we have to find that number. And AAPT will actually let us do this. If we search, we'll just grep for that exact string. And as you can see, here's this resource, and here's the code that we're using. Like I said, JAD has it in hex. So if we grep for that in our code, hopefully, we will find that we can see where this is being printed out. And sure enough, we found it in one place, like I planned it, where we're getting this resource and we're saying, well, that's not a valid word. So we're actually going to go to that and check out what is there and why that's saying that. Everyone can see this, all right? We're good? You want me to blow it up anymore? No? Okay. So I wrote down the line numbers because I knew I'd forget. 126. So as you can see, here's our hex value with, sorry, that's not a valid word. And here's the word check, says invalid word. That's not the place we want to get. If we look a couple lines above, we want to get to that, right? Valid word, yeah, that's good. So if P, which is a class method called P, that's a little bit of the obfuscation working for you. If P, valid word. So we want to make P return true. So we're going to go up to P, which is in this, line 55. And it returns Boolean, great. But we want to kind of go a little bit deeper than that, because if this is doing other stuff relating to the app, we don't know if this is going to trigger something like this big long line or something else in here is going to trigger something else in the app. So I like to go down as deep as possible. So we can see that flag is returned if there's not an exception. So this function, this really strange function that flag's being assigned from, we'll go check that out. Because I know for a fact, I tested it, that if you hook P and make it return true, it doesn't work. So we'll go down a little bit deeper. So there's a little bit of trial and error. So we'll go to this class, and here's the function that was just being called from P. So this function also returns a Boolean. And as you can see, word specified is not valid. So basically otherwise return true. So we want to make this function return true always. So this is the function that we're going to be hooking. This is the function that we're going to be looking at and running our module based off of. So now we've identified the code that we need to hook, and we can go check out our mod. Show mod code. Step 8. Okay, so this is the code. This should look somewhat familiar. These imports are all of the stuff that we talked about on that first import slide. This is just the full paths for them from the actual jar. And like I said, this code is online, so you can check that out after. Our Xposed hook load package, we're implementing it, implementing the handle load package function. And we're checking if the app name is com_Zynga words, which is Words with Friends' ID, package name. It logs, you're cheating, okay, it logs that just to let you know that it's on. And then it will hook the function that we had, com_Zynga words DAA. So in that class, this function. And then just returns true. So this takes a string, as we saw, and we're just going to make it return true. So the reason I'm hooking com_Zynga words DAA is because the path is com_Zynga words DAA, and the function name was A with a string argument, just so it clears it up. So I loaded this up, it rebooted, didn't crash, yay. And we'll go into Words with Friends, and this person's going to be unhappy, I think. So this is like the classic example. It should still have my word, too. All right, that was a lot of points. So That's the classic example. I'm going to resign because I feel bad for this person. So that's like the classic like function hooking example right there, where I can play whatever I want just by changing the return value of one function. We've got a couple more examples that are more relevant to security-minded people. So reverse engineering, I know. Extracting information, understanding code. If you're going to be reverse engineering an Android app, you're going to be looking at a bunch of a lot of really unimportant code and only trying to find a certain section. Or something that is in the code that's obfuscated or calculated afterwards. Obfuscated code or variables, they can be annoying to find, so if the app checks its own signature, you're decompiling, editing the Smalley code, and then recompiling is ruled out completely. You can't do that. You can dump, with Xposed, you can dump variables to the logs after they've been calculated. You just make the app do all the work for you. So let me make sure to, yeah, okay. So, let me see, yeah, no, okay. So, how many people in here have used or heard of Yik Yak? All right, good, I have a good audience then. So their API key is actually calculated based on the app's signature. So we're looking for that in the app. Let me just copy the first command. Good. The get bytes method is used on the variable when requests are signed. So if we hook that function, we can dump everything out to the logs, including the API key itself. So every time, as a side note, this app is heavily obfuscated, and like I said, it's the reason I wrote that shell script to unpack them. The obfuscation changes every time the app is updated. So practicing my demo, the app had updated itself because this is a slightly older version. It still will work on the new version. I just haven't taken the time to reverse it. My demo was just crashing over and over because I was like, why is this not working? You can't find that class, really? Because they get renamed every time the app is recompiled, which sucks. So out of a lot of reversing, I play with this app a lot. Out of a lot of reversing, I found that the API key is actually stored in this right here, and I'll spare you that huge explanation. But we want to find out where this is set and try to hook that function, or try to find out what this is actually doing. I'm not in the right window. That's got to be in the right project. So we're looking at where this is set, and luckily it's set in just this area. So we'll go into that file and check out why this is being set. This was line 36. Okay. So as you can see, the way this is all being calculated is this S1 is being fed in to this A.C function, AD.C function. And S1 is calculated based on the app's signature. And SHA-1, the base64 encoded SHA-1 hash of that. So that's passed into this AD.C function. And then the return of that is put into the API key. So we're assuming that AD.C generates this API key that's used to sign requests. This is the prime example of not being able to decompile it and recompile it, because if you decompile the application, if you unpack it and then try to repackage it, the signature will change. So the API key will change, so none of the requests will be valid. What's up?
You actually can do that. You just have to, another application can read what the signature of another app is, and then you just hard code what that signature is right there. That's one way to do it.
I had tried to do that, and the actual mechanism for calculating the API key is the next thing I'm going to show. I tried to just grab that code, extract the signature myself, and do it. But writing an Xposed module turned out to be a lot easier because it's hooking one function to just dump it out and give it to me instead of having to calculate it. So we can see that AD.C is what we're looking for. So I will go into that and show kind of where that's created. Line 370. So this is our C function within the AD class. It takes the MD5 hash of the input, that base64 encoded thing, and then runs this function A on the digest. And that function is on line 217. And essentially just does a bunch of shifting and ridiculous stuff on this array to calculate some sort of key. And the array that it's doing that on is essentially at the bottom here. It's just all the hex characters you can have. So we're looking for some sort of hex thing, and we need to dump that to the logs. So where to dump it? How do I know that the getPython function is relevant here? I know from previous research that each request has a user longitude parameter to it. So they're sending a request to an API via HTTPS, and I know there's a parameter called user long that's associated with it. So before every request, this is tacked on, and I'm assuming that they're going to sign it right around there. So this took a bit of work to get to that, but it's a good example of kind of associating things. So we'll look at this file, qf.jad, and as you can see, we're adding salt and hash. So whatever's in S4 is the hash that we're generating. So the API key is used to sign every request with a hash. If your hash value is not correct, then it rejects what you're trying to send it. So S4 is our hash, and S4 is being assigned from this function A, which I promise you is a function that just takes your basically your request URI, and then it will take the key, which is the API key that I was talking about, and it will do a keyed hash on it, HMAC SHA-1. And the key is the API key, and the thing to hash is the request URI. Those will both get dumped out to the logs, so we'll see those later. So essentially, we're using yikyak.a get bytes. So if we hook this get bytes function, we can just dump that straight out to the logs. It'll dump a couple more things, but we kind of know what we're looking for. Okay. So our module, this is a little bit more. There's two things in here because I use yikyak as another example. So again, Xposed load package, implementing that. Handle load package is our function that we're going to be overriding here, or implementing it. Checking if the application name is yikyak. And then we're loading the module. We're hooking the method getBytes here. So we're hooking Java lang string and then the getBytes method of that. So you can hook Java internal classes. Anything that's accessible to Java, you can hook pretty much. So we're creating a new method hook, and before it hooks that, we're just going to say this object, this string object specifically, just dump it out to the logs, prefixed by .bytes, so I can grunt for it fairly easily. So it's cool because you can actually access the object that's inside, or the object that this is being called on. So whatever string it is, I can grab it and dump it out to the logs. So now with any luck, I gotta close this first because it freaks out. With any luck, when I open the application, I'll be able to see that it dumps out. Yes, I would love to enable Wi-Fi. Perfect, thanks, yikyak. WPA2. It was connected to the wrong internet, that's why. Okay, let me go back to the app then. Nope, wrong one. Okay. So now our getBytes function, yeah, it's 2 out of 3 demos that work, I'm amazed. So our getBytes tag is here. We can see this is the key that we're looking for. And so if you, I've actually before they implemented more security, someone wrote up a big Python module to basically make requests to their endpoints. So you could add users, make posts, upvote, downvote things. And so they didn't implement security because people were just scripting downvotes of this, and it got wiped off the planet for a couple days. So that's the key that they're using to sign every request. And now if we have that key, we can throw that in that application and actually query like the RIT yikyak from where we are right now. So as a side note, let me actually refresh the page here. As a side note, this right here, this API, get messages, accuracy, this is the endpoint's querying, this is what it's hashing. So it's hashing this HMAC SHA-1 hash, this with this key. So now, with that API key within that module, we can actually see that we can get the yikyak feed from their API with a Python script. So we're using that to sign requests to their server. Yeah, they're pretty bad. If you haven't heard of yikyak before, it's essentially like 4chan in like a 10-mile radius. It's terrible. All right, we'll get that off the screen. All right, I got to disable the mod to show you guys the next part, and then reboot. So let me do that.
Hey, Jamie.
Yes?
You replaced your line of code there with a C. Yeah.
That's fine. I wanted to do that. All right. So we'll disable that and reboot. So disabling security checks. So if you've ever reverse engineered an application, an Android application, and tried to figure out what it's doing, reverse engineering the application and figuring out how it's building its requests to stuff is way harder than actually just man in the middling. If you can man in the middle, you can see what it's doing when, and you can actually just grab the requests. So we're going to do the same thing with Yik Yak, and I'll talk about that on the next slide actually. So if the app employs certificate pinning, you're out of luck pretty much. You need to disable that somehow or manually reverse engineer it. You can disable certificate pinning with Xposed, so we'll do that. So our second practical example is Yik Yak again. They employ certificate pinning. So essentially what happens when you open the app, and I'll show it, and you're trying to man in the middle, it will say, no, I can't be man in the middle, and say, you have no internet, which is obviously false because I have plenty of internet. So through a bit of reversing and figuring out things, I learned that the SSL pure unverified exception is thrown when the certificate is unknown. So we're going to basically find that in the code and hook the function that's throwing that to do nothing. So we'll man in the middle some stuff. How am I doing on time? 10 minutes, that's perfect actually. So rep. Yeah, rep it. Okay. So we're going to grep in our decompiled code. Like I said, I saved you the decompilation step because it takes a little bit to go through everything, especially with this because there's so many classes. Let me actually show you all of the class names. They're ridiculous. I added the numbers because they were the same name, and like I said, I don't have a case-sensitive file system. So let me just grep that again. So it appears in a couple places. I tried out most of them, but we'll go with the first one because that's the one that actually works, and because it's the first one, right? All right, let me go back to my code here. Glad I decided to record all these commands. So we have this function that throws a pure unverified exception at the bottom. So here's that. So we don't want it to do that. And as you can see as well, certificate pinning failure. Okay. So this string builder is the thing that's returning. The string builder 2 strings, what it's returning as the exception message. And so as you can see here, it says certificate pinning failure. We want that to succeed, right? So we don't want this function to happen at all because it's going to throw an exception. So we'll kind of make note of the arguments it takes, a string and a list, and what it's called, A. So nc.a with a string and a list. So now I'll show you guys and if you haven't used Visor, by the way, this is what I'm using to put my phone up on the screen. I was thinking about how to do this talk, and I was like, can I hold my phone up or use an emulator or what? But this is actually a lot better. So I'll show you guys that without this enabled, it yells at me and it says internet connection. The internet connection appears to be offline, which I'm definitely online. I know that. I've got Wi-Fi that has internet, so it's something's going on. Right now I'm trying to man in the middle of traffic. I have a certificate installed from Burp. I have Burp Suite running over here, and it's grabbing stuff. So if we go back here, and we'll show the module code before I re-enable. I'll re-enable it now, and then while I'm showing the module code, it'll reboot, and we can show that it's actually. I put it here for a reason. Modules, yeah, enabled, and okay. So this is the same module we looked at before, but I didn't explain this line of code, which is disabling certificate pinning. I also have an example in here of replace hook method that just logs whatever string is passed and then returns null. Find and hook method nc.a, that was our class and then function name. First argument is a string. Second argument is a list, and then Ellen. That loves attention. And then we're replacing the method, and we're just saying, hey man, just don't do anything. All right? So we don't want it to throw that exception, so if it doesn't run, it's not going to throw that exception. That function, you may be saying, well, what if that function does something else? That is where things get complicated, and you actually have to start really digging into this and figuring out what to do. But like I said, this is a basic intro to the Xposed framework and how you can hook stuff. So I figured out that it doesn't do anything else besides certificate pinning. That's all it checks. So if we just don't do it, then it'll be fine. All right. Waiting for my phone to boot up. So Burp Suite's running. You guys, how many people have used Burp before? Burp Suite, right? Yeah. Proxy, get in the middle. The issue is here, HTTPS. We need a cert. You can install the cert within the Android certificate store, and that'll allow you to man the middle traffic that's not certificate pinned. So if it verifies the certificate, you're out of luck. And so basically that's what we're disabling within this application. So waiting for my phone to move. It's going to yell at me. Yeah. Any questions while we're here? This is my last part, so go ahead.
Did you publish that Python script that pulls down the yik-yak stuff?
Yeah, it's somewhere on the internet. I did that. I had that from a while ago. It wasn't mine, but I had like made changes to it so that I updated it so that I could query it again because they've changed their API a little bit since. It's kind of broken right now. There's a lot of features that are not there, like message posting and upvoting and downvoting, because I think they're rate limiting now. You used to be able to just downvote things like continually, and now you can't do that anymore. They've actually improved their security, which is good for them. But I think it's somewhere up in the end. It's called PYAK, PYAK, and there's some code that I've contributed to that I'm not sure if it works anymore. I have to fix it. But if you guys want to, I can publish just the part that gets the messages and prints them out to the screen.
Sure, yeah.
So you demonstrated method hooking with objects that are from the Java standard library.
Mm-hmm.
How is the framework capable of hooking functions that take objects that are defined inside of the class definitions inside of the application?
Yes, but you need to basically get the decompiled code and like make it acceptable for reading because it needs to know what the class is to be able to accept it. You can recreate it. You have all the code, so you can recreate it. That's a little bit more painful, and that's kind of outside the scope of this talk because it takes forever to do that. If you're looking for a cool example of that, one of the projects that I follow and has helped me develop this talk really a lot is on the last slide, and I'll talk about it when we get there. Good.
Just more of a comment with a slight question. So you sort of mentioned you couldn't really do anything too terribly nefarious with this, but one of the issues I've seen with Android AppSec is that it's pretty bad.
You're not wrong.
No. So immediately my first thought is, let's try and hook something that's doing client-side input validation.
Mm-hmm.
Have you encountered anything with that? Or? I mean, I've seen a couple apps, but...
I mean, yeah, like, Words with Friends is that example. Like,
Well,
that's
exactly,
the client-side
sure.
validation, yeah.
Sure, but something maybe a little bit more nefarious, something
More
that's
useful,
actually
yeah.
doing, like, parsing for SQL injection.
I haven't looked into that. And that's definitely something that's like, my idea with this talk was I have these applications that I know work and are fun examples.
Yeah.
But this is definitely, like I said, extendable to whatever else. If you can write a module, if you can think about the module, like if you can think about a function that you want to hook with inside the application, you can change its functionality. The reverse engineering is, like I said, was about half this talk, and is a big topic that people really need to get farther into. And that would have a whole 2-3 talks devoted to it itself. So if you can find it, you can change it pretty much with it. I hope that answers your question. Somewhat. All right, so now we'll launch the app, and we'll see, hopefully, cross my fingers on my last demo, that it will grab the yaks. And at this point, we can go over to our burp. I know this font's small, I'm sorry. And we can see that it's querying the API successfully. And I'll actually just put this in a Vim window and just show it to you here. Copy. And so we can see that here's the API, here's the actual query to the server, and we're man-in-the-middling all the traffic now, and it's not yelling at us because, oh, hey, you're not connected to the internet. We disabled the certificate pinning check, and now we can get all the traffic in the middle, and we don't have to spend the time reverse engineering that whole section of code that compiles this whole request, so we can see them as they happen. So, getting messages or posting things, or upvoting, downvoting, whatever. All right, so other resources in the code. The code from this presentation, the reversing tools, the APK decompiler script, and the string search script are on there, as well as the module or the unzipper. Xposed mods has a couple mods. There's one extra. There's a fun module that will monitor Google Play Music for Taylor Swift songs and skip them. So I thought that was fun. It's an interesting thing. It's an interesting module to look at as well because it accesses class attributes. It's a kind of a me practicing accessing class attributes. So song name, I had to figure out what the hell that was and resolve it dynamically. So that's a really cool little thing. There's a development tutorial by the guy that created the Xposed framework. He actually, his small little tutorial is change the clock red. Like change the system clock red. So he actually has an example of hooking Zygote, which is that first process, and looking for the actual Android UI. So you can hook things within the Android UI, not just within applications, but that was kind of outside the scope of this talk. The XDA forum, there's an XDA forum for everything Android, and there is one for the Xposed framework and module development and modules themselves. So go ahead and check that out if you're interested. The Xposed source code was something that I looked at a little bit, just interested in it because it was just, it's a really cool project, and the guy that maintains it, the guys that maintain it are it's just mind-blowing stuff how they came up with this, and we're just going to rewrite app process, like, great. SnapPrefs is the app that I was talking about, Brad. SnapPrefs, the source code for SnapPrefs is great. They have stuff on obfuscation, like doing deobfuscation for Snapchat. It's basically a big Snapchat library, so you can like no screenshot notifications. I think you can change the weather. You can make it so you're like going 1,000,000 miles an hour, extra filters, stuff like that. It doesn't work currently because they don't update it that much, but if you guys want to submit pull requests, I'm sure you would love them. The source code is there, and that has a lot of examples of hooking stuff, a lot of creating your own UIs. If you're looking into hooking UI elements and things like that, that's definitely a project to look into. And I did well on time. Wow. Any other questions from you guys? You're more than welcome to approach me afterwards. And yeah, thank you guys for listening and coming to this talk.